last lecture we have seen three different laws. Okay, first is a arithmetic laws, second is a geometric progression law, and third is a harmonic progression law. Why these laws are required we have seen. To find out the different spindle speed steps, find the relation of two speed steps. We have seen the definition of each law. Okay, then next one is a see in this figure you have given the cutting speed meter per minute, means the spindle speed is directly proportional to the 1 by d, means cutting diameter. You know the formula V is equal to pi dn divided by 1000. When we carried out operation at a specific cutting speed, it depends on that two variable, diameter of the given component and n is the spindle speed. Remember that. Then see, we will get the formula. If you have simplified this formula, then you will get n is equal to 1000 V divided by pi d. Okay, you know that. We have seen this arithmetic progression law. Okay, we have calculated all this. It is the ratio, it is the difference between two successive spindle speed is constant. Okay, and how to calculate the n1 to nz value, already we have seen this. We will see the one example of the arithmetic progression law. See, if you have given the maximum spindle speed is nmax is equal to 445 rpm, minimum spindle speed is given 35 rpm, and number of speed steps are given 12, it is denoted by the z, and cutting speed V is equal to 20 meter per minute is given. Okay, then how to calculate the common arithmetic ratio? With the help of this formula we have seen AT is equal to n2 minus n1. Okay, and delta decay is equal to, this is the diameter range, it is the difference between d2 minus d1, means upper limit minus lower limit. Already we have seen. See, if you have calculate with the help of that, here is a number of spindle speed steps are given 12. If you have calculate that spindle speed from minimum to maximum, means n1 to n12, then you will get the different value. See, n1 is equal to 35, n2 is equal to 72.27, n3 is equal to 109.54. This value will be increased, and if you have observed this n12 up to, then you will get the maximum value. Means though this value are given in your problem statement data, 445 and 35 rpm. This is the 35 rpm and we want to achieve 445 rpm. Okay, if you have calculated the phi value, then you will get the different phi value for that different spindle speed. If you have checked here, you will get the 2.07, then 1.52. This value will be reduced, then again check that at the last 1.09, you will get this. If you have calculated the upper limit, okay, then again you can check. First you will get the maximum value for the upper limit, then this value will be reduced. Okay, this value will be reduced. And if you have checked the range of the diameter, then check that if we have the speed 35 rpm, then we will get the range of that diameter is 93.8. okay, if the speed is increases, then diameter is range is decreases in the arithmetic progression ratio. See, we have observed that in arithmetic progression at a low spindle speed, check that at at a low spindle speed the diameter range is very wide. Okay, and here is need to add more speed steps between that calculated value. We want to the again add the some steps, whereas if we have checked at the last high spindle speed the diameter range is very poor. If you have checked the N10, we have the spindle speed 370 and diameter range is a 1.58, is very narrow, and hence we want to the redundant some speed steps from this. Okay, here we want to the add some speed steps and here we want to the redundant some speed steps. Okay, in the arithmetic progression ratio. That's why see the remark of that this law is poor in low spindle speed range, poor in low spindle speed range. Similar way we want to the check the geometric progression ratio. All of you getting? If the we required this spindle speed is a 35 and here is a diameter range is a 93. If the spindle speed range is increases but diameter range is decreases. Okay, that's why this law is poor in low spindle speed range. Then second, see this is the arithmetic progression law. Already I have explained. At the high spindle speed the diameter range is very narrow and hence some of the speed steps are redundant. What is the advantages of AP and HP? HP means harmonic progression ratio. This is the simple gear train arrangement if you have seen that. And what is the disadvantages of AP and HP? There we are use only the two shafts. Okay, if you are using the only two shafts then number of gear pairs are more increases. Axial size of the gearbox, this size also should be increased. This is the disadvantages of the arithmetic progression law. We have seen the geometric progression law. In the geometric progression law is nothing but it is the ratio of two successive spindle speed is constant. We have seen how to calculate range ratio. It is denoted by Rn and max divided by n minimum. See, then we have seen this formula already. Check that. Again, if you have take this ratio, range ratio, then see the we will take the same example we have seen in the arithmetic progression law, right? Then see how to calculate the Rn. How to calculate the Rn, n max divided by n minimum, or you can use the simplification formula phi is equal to Rn raised to 1 divided by z minus 1. Okay, phi is nothing but it is the ratio of n2 divided by n1 or n3 divided by n2, same as. Okay, then see here is again number of spindle speed steps. Speed steps are given 12. Okay, minimum speed is given 35, maximum speed is given 445 and max. Okay, then see what happened if you have checked the phi value, means this geometric progression ratio is constant. If you have seen the arithmetic progression law, there will get the different value for this progressive ratio. Okay, if you have checked the decay is equal to, then you will get the 181.89. This is the diameter, upper diameter, then this will be reduced up to the 14.3. If you have checked the diameter range, then you will get again 37.53 to 3.73. If you have checked this relation in between that two, okay, spindle speed and diameter, the range, then check that n1 is equal to 35, then here is the diameter range is a 37. Here is also same thing is here. This speed is increases. If you are checking this first three steps, then check that this diameter ratio is also reduced. If you are getting the maximum speed, spindle speed, then again here the diameter range is reduced. Hence, multi-speed drive with geometric progression is poor in spindle speed range. Okay, here is also we want to the add the some speed steps, and here is also we want to the redundant some speed steps. Okay, both things. Then see the remark of that arithmetic progression law and geometric progression law. At low spindle speed, the diameter range is wide, hence need to the add more speed steps between calculated value. Same thing is here. By using this GP, the speed is reduced uniformly in different stages. If you have checked, the speed is reduced uniformly, but if you have checked in arithmetic, then speed is suddenly reduced. Speed is suddenly reduced, and also diameter range is also suddenly reduced. Okay. Then see again comparison of the AP and GP. There I have shown the speed steps. You have given 1 to 12. Then we have find out decay value. Say for the arithmetic progression, here is a 181.89, and second value we have 88.09. But if you have seen in the geometric progression that decay value, check that 181.89, and second value is a 144.36. Means this value is dropped uniformly, but in the arithmetic progression this value is not dropped uniformly. Okay, this is the variation in diameter is wide in AP than GP. Okay, if you have compare AP and GP, then you will get the more variation in diameter is wide in AP as compared to the GP. Then which law will select? Check that. Then again see in the arithmetic progression, this is the complicated, also expensive gearbox because of more gear pairs on that two shaft. On that two shaft, here is a more gear pair. That's why this will be complicated and expensive. If you have compared to the GP, then see here you will get the compound, or we can say the compact gearbox. Okay, this gearbox is a less gear pair because we are increase the shafts. Here you will get the 3 shafts, 1, 2 and 3 shafts, but here you will get the only 2 shafts. Then you can shift the gear pair on the different gear. Okay, that's why GP gives the optimum distribution of gear speed compared to the AP. How? Check that. Okay, in this table you can check the spindle speed also in the arithmetic progression law. Here is the spindle speed is given 35 RPM, and here also we have the same spindle speed. But if you have checked the second speed steps, then you will get the spindle speed is a 72.27, and here in the GP we will get the 44.1. Okay, means these are suddenly increases, but these are uniformly increases. You can compare this. Okay, then which law is better, or what is the advantages of the GP? Okay, we'll see the comparison. See, if you have seen the advantages of the GP, there is a multi-speed drive with the geometric progression gives the constant loss of economic cutting speed in total speed range. Okay, if you are checking, then you will get the constant loss of economic cutting speed in total speed range. How to get that constant loss of economic cutting speed? We will see the details. And second better advantage is better gearbox design feature having the geometric progression ratio. Because if you have also seen the phi value, this phi value is constant in geometric progression, but in the arithmetic progression you will get the variation in the phi value. Okay, see, if you are getting the comparison, the arithmetic progression, geometric progression and harmonic progression. Okay, then see the the definition of all. First is a arithmetic progression. Yes, this is the difference between any two successive spindle speed is constant. We have seen in geometric progression the ratio of any two successive spindle speed is constant, and in harmonic progression the difference between reciprocal of any two successive spindle speed is constant. Remember that three definitions. We have calculated the z spindle speed in each and every progression. Okay, we know the formula nz is equal to n max plus or minus n minimum divided by z minus 1. Okay, then here we have calculated the geometric progression ratio phi n max divided n minimum raised to 1 divided by z minus 1, and in the harmonic progression nz is equal to what? N minimum divided by 1 minus z minus 1 into c n max. C is given for the constant. We know that. This arithmetic progression good in high spindle speed range, then geometric progression good in high spindle speed range, and harmonic progression good in low spindle speed range. And last is this arithmetic progression poor in low spindle speed range, geometric progression poor in low spindle speed range, and this harmonic progression poor in high spindle speed range. We have seen with the help of example. See, this is the terminology is given. Okay, number of spindle speed steps are given. Number of speed steps are given. Here is a z is denoted by number of speed steps is equal to number of speeds. Okay, total number of speed steps, suppose you have given the 12, then here you will get the number of speeds 12 speeds, and n is given for the number of stages. Okay, or we can say the number of stages is equal to number of transmission group. Okay, transmission group, it is denoted by the tg. Okay, remember that, number of transmission group. Here one example is given. 4 speed gearbox is given, means z is equal to number of speed steps are 4. Okay, 4 is there. Then check that there are 2 shafts we are using. If we are using the 2 shaft, then there is only one transmission group. Okay, if we are using the 3 shafts, then there are 2 transmission group or 2 number of stages. Here is a 2 shafts we are using, that's why we will get the number of stages is equal to 1. Okay, if we have seen the pair of that on the first shaft, here is you will get the 1 2 3 4 and 5 gears are there, and here is these 4 gears are engaged with that 4 gears. 4 gears are there on the first shaft, and second shaft also you will get the 4 gears, both are engaged. If you are moving left and right side, then they will be engaged to each other. Here is some examples are given. See, again z is equal to 6 speed gearbox is given, and there is a number of stages. 2 shafts are given, input and directly output shafts are given. That's why you will get the number of stages 1. How to calculate that number of stages, I will tell you. Okay, then 6 speed gearbox, here is a 2 stages. Why 2 stages? Because of number of shafts you have given the 3. 1 2, in between that 1 and 2 there is you will get the 1 stage, and second and third you will get the second stage. See, here is one animated figure are shown. 9 speed gearbox and 2 stages. Here is a 1 2 3 shafts are given, and z is equal to 9. Z is equal to 9. Means you have to check there is a number of speed steps in the first stage. Check that this figure. I will explain this one, how to get this number of gears on each shaft. Okay, with the help of this. P is the number of speed steps in each stage or each transmission group. Okay, this is the shaft number 1 and shaft number 2. In between that you will get the first stage, remember that, and second shaft and third shaft. In between you will get the second stage. Okay, and what is the value of P1 and P2? Okay, you know the formula. There is one formula is given for that. Okay, you have to calculate this value of Z. How to calculate the value of Z? Z is equal to P1 into P2. P1 into P2. Okay, there are some selection criteria is given for the geometric progression ratio in multi-speed gearbox. There is a number of speed steps is equal to P1 into P2. Means what is the P1? Number of speed steps in the first stage and number of speed steps in the second stage. Okay, total number of speed steps they have given the Z. Z is equal to 9. You can choose this value of the P1 or P2 is 2 either 3. Only 2 or 3 you have to choose. Then you will get the number of speed steps. Okay, Z is equal to 3 into 3, you will get the 9. Okay, if you have choose the P1 value is equal to 2, then you will get the 2 into 3, 6. This answer is wrong. Okay, remember that. That's why we want to the use here P1 is equal to 3. Means here you will get the number of speed steps in the first stage are 3 and second stage also 3. Okay, then use this formula Z is equal to P1 into P2. Put the value of P1 and P2 2 or 3. Here we want to put the value 3 into 3, then you will get the 9. This is the terminology to select the speed steps. Okay, total number of speed steps and speed steps in between the shaft 1 and 2 and 2 and 3. You will get the number of speed steps in the first stage and number of speed steps in the second stage. Q is given for the similar speed steps. Similar means in the first stage, check that P1 is equal to 3 and second stage P2 is equal to 3. Means you will get the we can write P1 is equal to P2. P1 is equal to P2 and you will get the Q value is equal to 2. Similar speed steps. This one and this one you will get the 2. Okay, 2 similar speed steps. Similar way, check that here 12 speeds and 3 stages are given. 3 stages means here you want to draw 3 shafts. 3 stages means 4 shafts. Then you will get the 3 stages. In between first and second you will get the first stage, second and third you will get the second stage, and third and fourth stage. There is a electric motor is directly attached to the input shaft. Okay, and here is a output shaft. Fourth number is a output shaft. This is the input shaft, this is the output shaft, and these two are the intermediate shaft. Then Z is equal to 12 is there. We have the formula 12 Z is equal to P1 into P2 into P3. How to get this? What is the value of P1, P2 and P3? How to decide? You have to choose either 2 or 3. If you are putting the P1 is equal to 2, P2 is equal to 3 and P3 is equal to 2, then you will get the 12. Otherwise, if you are putting P1 is equal to 3, then check that 3 into 3 9, 9 into 2 18. This answer is wrong. Okay, similar way you have to given the some example. Before going on that, you have to calculate the again similar speed steps. Q is equal to here 2 similar speed steps in the P1 and in the P3. We can write P1 is equal to P3. Check that P1 is equal to P3. We have drawn the same also here if you have checked. Then see similar way, if you have given total number of speed steps Z is equal to 4, then again you have to put Z is equal to 2 into 2. we want to the choose the value of P1 and P2. This value is at 2. You will get the 2 into 2, 4. And how many number of stages? Here is a 2 stages, means 3 shafts and 2 stages. And similarly again you will get the Q is equal to 2. 2 into 2, again 2 P1 and P2 are similar. That's why you can choose the Q is equal to 2. Z is equal to 6. Z is equal to, you have to choose the P1 is equal to 2 and P2 is equal to 3. If you choose P1 is equal to 3, then you will get the 9. This is the wrong answer. That's why 2 into 3. You will get the again number of stages 2. Number of stages 2. Then Q is equal to 0. There is not similarity. That's why 0. Z is equal to 8. 2 into 2 into 2. You will get the 8. N is equal to 3. Number of stages also 3. Check that number of stages. How to calculate? This is the first stage and this is the second stage. Okay. Q is equal to again 3, because P1 is equal to P2 is equal to P3. That's why 3. Z is equal to 9. Again 3 into 3. P1 value is 3. P2 value is 3. That's why you will get the N is equal to 2 and Q is equal to again 2. Okay, this is the some examples. Okay, you have to remember that example. Okay, then next part is this is the important part. Sometimes you have to ask, what is the advantage of the geometric progression law? Out of that 3 law, arithmetic law, then geometric progression law and harmonic progression law, we will choose the geometric progression law. Why we are choosing the geometric progression law? Because this is the first advantage. There is a constant loss in economic cutting speed, okay, in the total speed range. That's why we are choose the geometric progression law. And second advantage is a better gearbox design feature. Okay, there is only one advantage. Disadvantage is a poor in low spindle speed range, but both we get the better advantages. Okay, first is a constant loss in economic cutting speed. How to get the constant loss in economic cutting speed? We will see the details. Constant loss of economic cutting speed. Check that here is a, if you have seen the figure, that cutting speed versus the diameter of the workpiece here is shown. We have choose the speed steps 12. Already we have seen this example. Then you will get the total number of spindle speed are also 12, and decay value, this is you will get the 12 values. Okay, we know the formula. Cutting speed is equal to pi d n divided by 1000, and n is equal to 1000 v divided by pi d. Okay, here I have shown this graph is cutting speed versus diameter of the workpiece. Let's check that this n1, n2 up to the nk, n1, nk plus 1 or nz is the, we have seen the, what is this? Different spindle speed, and z is the total number of speed steps. D is the, here shown the d1 and d2, diameter of that workpiece, and V optimum is given. Okay, this is the optimum cutting speed. Optimum cutting speed is there. If you have seen the spindle speed corresponding that optimum cutting speed, how to calculate this? N optimum is equal to, here is a 1000 V optimum divided by pi d. Here let's assume that the optimum spindle speed is N optimum. Okay, here we will assume that this optimum spindle speed is a N optimum. Okay, between that two spindle speed, N1 and N2, or we can say the again Nk or Nk plus 1 is there. Okay, shown in that graph. In spindle speed is selected for the cutting operation should be either the N1 or N2. According to, we want to choose the cutting speed will either V1 or V2. Okay, according that spindle speed, we want to choose the cutting speed is a V1 or V2. Okay, then again what is the V1 and V2? V1 is equal to, we can write pi d n1 divided by 1000, and V2 is equal to pi d n2 divided by 1000 is there. V1 and V2 is the economical cutting speed is there. Okay, then loss of economical cutting speed is nothing but the difference between the actual cutting speed and the optimum cutting speed. Actual cutting speed is V1 and optimum cutting speed is known as the loss of economic cutting speed. If you have checked the range of that cutting speed delta V1, we can choose the V optimum minus V1 or V optimum minus V2. Okay, this gives the difference between the actual cutting speed and optimum cutting speed is known as the loss of economic cutting speed. When we will get the maximum loss of economical cutting speed? When this delta V max is equal to, you will get the Vk minus V optimum. Okay, at that time you will get the maximum loss of economic cutting speed. Then see that we'll use the delta V max is equal to V2 minus V1 divided by 2. V2 minus V1 divided by 2. If you are putting the value, then you will get the delta V optimum is equal to V2 plus V1, V2 plus V1 divided by 2, this V optimum. Okay, if you are dividing delta V max by V optimum, then check that we will get the delta V max divided by V optimum is equal to pi minus 1. Again n2 by n1, we have seen the geometric progression ratio, and n2 by n1 again geometric progression ratio, pi minus 1 and pi plus 1. Finally we get delta V max is equal to pi minus 1 divided by pi plus 1 into V optimum. Check that this pi must be constant. Pi must be constant. It is possible in only the geometric progression law. That's why this loss in economical cutting speed is in constant in geometric progression law. This is the advantage of the GP. Okay, optimum distribution of gear speed, then constant loss of economic cutting speed and better gearbox design. Check that effect of the GP ratio. GP ratio is here 5. If the GP ratio 5 value is lower value, then what is the loss of economical cutting speed? You will get the minimum. What about the speed steps? There is a large number of speed steps. What is the compactness of drive? Complicated drive or expensive? If the value of GP is higher value, then we will get the maximum loss of economic cutting speed, and speed steps is a smaller number, and we will get the compact drive. To compressive between that loss of economical cutting speed and compactness of drive, this value of GP ratio phi must be less than or equal to 1, or phi must be less than or equal to 2. Remember that. Today we will stop here. Next lecture we will see the remaining part.